They're in order. They're in order. Yes, let's continue, guys. Sorry for that. Someone is collecting the script. That's why my attention was divided. Sorry for that. So let's understand one thing here. The given table indicate the means, right? The given table indicate these are the means. So everything that we see here, we see the means in it. So it means what I will need what? Filter. Which one is your treatment? You did the question. He said, Mr. Elmo, which said which one is your treatment? Filter is the treatment. And then operator is the block. How many replications do you have? This one treatment, we have 2.
Yeah, 2.
In blocks. Replications, how many replications do we have?
2.
Which is R. Yeah, you can go and check it, my brother. When you're not happy, you come and complain. So when you're not happy, feel free to come. So let's perform pairwise comparison for treatment using the LSD method. How are we going to do it? It means we need the MSE, isn't it? MSE, you have the solution for this. What is your MSE? And what is the degrees of freedom of error?
5.1625.
5.1265. And then the error, degrees of freedom of the error?
It's 4.
It's 4. So now let me branch back to the black color now. So
Says
LSD
1625.
1625. The LSD is given by T alpha over 2 degrees of freedom of error multiplied by the square root of 2 MSE over B, because our focus is on the treatment, right? So we'll divide by the number of blocks. Our focus on treatment, get this one right. Our focus is on the treatment. So we'll divide by the number of blocks, multiply by the number of replications. So what is the answer? What is the answer here? You want to check if there's a difference between filter 1 and filter 2. Guys, I'm listening.
Is 4.46. 4.460.
Okay. Here's the value. So do the comparison of the filter. Remember, I'm focusing on the filter now. Mean I dot dot bar minus mean I prime dot dot. What is the answer? So it means you're saying 15.5 minus 22.85. You're saying it's what, my brother?
7.35.
7.35. So there's a difference between mean 1 and mean 2, right? From the ANOVA table.
Yes.
You see? So you see, I didn't even follow the order, because if I was testing, I was supposed to first check the interaction effect. So what is happening when coming to the interaction effect? Are you rejecting the null hypothesis or failing to reject the null hypothesis?
We
For
failed.
the interaction effect?
We fail.
You didn't reject.
Yeah, we
Wait,
failed to reject.
You didn't reject, right?
yeah,
Yes.
So the problem we cannot. It's fine. Just for the explanation purpose, can you please find the what? Let's check if the means for the block, which is the operators, is significant or not. The mean for the blocks, what will be the formula? The mean for the blocks, the operators, means it will be operators. Operators, the LSD for the operator will say T alpha over 2 degrees of freedom of error multiplied by the square root of what? 2 MSE. We're going to divide by what, guys? We're focusing on the operator now. We're focusing on the blocks.
we're
It's
going to divide by T.
TR.
So we're going to divide by TR, isn't it? Because we're focused on the block. The one that we're focusing on, it won't be there. You understand? The first one, if you check, relate the two. This one, our focus is on what? Our focus, it was on the treatment, isn't it? We divided by what? BR. Now the focus is on the block. We divide by what? TR. So you use that formula there to find. So the one that is very, very important now is this one. Block by treatment, which in your case is operator by field. So this one, the LSD is given by T alpha over 2 degrees of freedom of error multiplied by the square root of 2 MSE over, because now we're focusing on the block. Let's get these formulas, even though you said you want the formulas. This is the block and this is the treatment, isn't it? What is not here is what? Yijk. What is not here is what? Is the replication, isn't it? So you divide by what? By R. So the question that we may ask is, which means are we going to use? The means that we're going to use are these ones. The means that we're going to use now to do this pairwise comparison are what? The means from each cell. Do you see it, guys? Now you want to check for the interaction effect. So you use the means from each cell. So how many means do we have? We have 4. So what is going to happen is that so you will have, because the table, if I want to summarize the table, it means it's operator and then filter. The first value there, let me write like this. The first value here is y11 dot bar. The second value is 12 dot bar. This one is y21 dot y22 bar dot. The dot represent what? The replication. So you have how many comparisons are we going to have in this case? How many comparisons are we going to have? How many means do we have?
We're going to have 6 comparison.
6 comparisons, isn't it? So
Yes.
that one, the only part that I think you needed for me to explain it was what? The formula part, this part here. So whatever you have, you divide with R when you want to find what? Blocks by treatment interaction effect. So the comparison will be Yij dot minus Yi prime J prime dot. So these are the means. These are the means of what? These are the means of each and every cell. So when you want to do pairwise comparison for the interaction, you use the means for each and every cell. For this type of the good thing about these questions is that the replication is always equal. The replication is always equal. So without that, guys, allow me to move to the take one now. This whatever we're doing here, it was related to what? To the LSD method. If we are asked to use the take now, taking method for blocks by treatment problem, block by treatment problems. The takey, remember, pairwise for takey, focusing on the treatment, treatment means the formula will be T alpha Q alpha TF multiplied by the square root of MSE divided by what, guys? We're focusing on the treatment. We have TB. Sorry?
We divide by B.
Yeah.
Why B?
Because we are focusing on the treatment. Is our.
What about R?
It's BR, sir.
It's BR, is it, my brother?
Yes, sir.
Because our focus is on the treatment. So, and the confidence interval will be what? So, sorry, let me write it here. Confidence interval will be yi dot bar minus y bar I prime dot. Oh, sorry, this is because this is a confidence interval. This cannot be what? Cannot be absolute values. Plus or minus T alpha. Any question there? This one is for the treatment. Let me say number one. Number two, for block by treatment, still take it. T alpha will be given by Q alpha TF multiplied by the square root of MSE divided by, give me the answer, guys.
R.
R. Because the treatments are involved, which is represented by T. The blocks are involved, represented by B. The one which is not represented what is the R. That is why we will divide by R. And the confidence interval for this will be given by Yij dot bar minus Yi plus or minus T alpha. Because now our focus is on what? It's on the cells now. So this is the formula that you'll use. So can you please find the when testing for the treatments, can you please calculate here? We'll have what? Let's calculate We'll have Q of 0,05. How many treatments do we have? We have 2. Degrees of freedom of error, I'm told, is 4, multiplied by the square root of, I have this value somewhere. I was given the value by some of the leaders. I was told the MSE is what is the MSE?
5.165.
5.1625. Sorry. 5.1625. So you can do the calculations here. 5.1625 divided by 2. What are you getting there, guys? Or what is the value from the table?
So I think
This
we
part
divide
here.
by 4.
Why 4? R is what? R is 4 or is 2?
R is 2. And
Yes,
B
you
is
divide
2
by the number of
also.
replications.
Are we not
Which one are we
doing the
doing?
first one? Are we not doing the first one?
Yeah.
Oh, sorry, yes. I'm on the multiply by number of replications, which is 2, based on this one. Sorry for that. I missed your point. Sorry for that, my brother. Thank you very much for that. So I was saying, what is the tabulated value?
It's 3,927.
3.92. Can someone confirm this value? 2 and 4 from the student task table.
Yes, it's correct.
So you calculate, right? And then you do the comparison. You need the absolute values. So let's also move to this one for the blocks by treatment. You'll calculate these things on your own, as long as you have the idea on how to do them. So this one, I'm told, is 3.927 multiplied by the square root of 5.1625. This one is the one that we divide by 2, isn't it? So the same idea goes to the Newman curls and Duncan. I will show you how to do it, but it won't change because there's not an error for. It won't change. What is the answer for the first one?
It's
It's 4.
4.46.
This one.
Yeah,
Yes.
it's 4.46.
And the second one?
6.31.
So it means here you said we have 6 comparisons. You will do them. 6 comparisons. But with this one, we have only 1 comparison, isn't it? Because we have only 2 means. So you only compare that value with whatever the difference with 4.46. With the interaction part, it means you have those 6 comparisons. You'll do the mathematics there. So allow me, sorry if I'm rushing, allow me to show you the last one. If I show you the turkey, or this time let me use the Newman curls. Because in the morning I use the Duncan, but the procedure is the same. So for Newman curls, method 3. Step 1 is the same. You arrange the means. Step 2, find the standard error. That is, allow me to write the two of them here. That is, if we are testing for the treatment, the standard error is given by Mr. Lwo? Okay. The standard error if we're testing for the treatment is given by y. The square root of, we are testing for the treatment. We agreed that this is MSE over BR. This is the first one. And then if we are testing, come in, Mr. Lwo, for block, no, it's fine. Oh, block by treatment, the standard error will be given by MSE over R. The rest is the same procedure. It was after getting this part here, to know how many values you need to collect from the student times table, you are guided by the number of means. For example, based on our class example, when coming to this one, you said we have 4 means, isn't it? We have 4 means. It means we need how many values from the table? We need 3. But the rule says arrange the means in ascending order, so that when coming to the comparison, you don't struggle. So the other steps remains the same. Together with the confidence interval. Any question, please? Let me go back. Any question? Feel free, guys. Any question that you want to ask?
Sir, Mina, I do not
Yes.
get that part of dividing. Like, I need to send card.
Dividing what?
The one for dividing by B. Let me check. The one for BR and R.
No, that one I said, Mr. Mabunda, when you write the model, what is the model? That's fine. Let me go to the next page. The model, Mr. Mabunda, for blocks by T is given by what? Y, I, J, K, isn't it? This is the population mean. Let's get it from here, Mr. Mabunda.
Yeah.
I goes with what in this case?
With the treatment.
With the treatment, right? Because you attach the I to the treatment, isn't it? So if you're saying I goes with the treatment, J will go with the block. It's not always the case, ne? And then K will go with the replications, isn't it?
Yeah.
Let's go to the formula for, before we can even go to the confidence interval. It takes us back to, suppose you want to find SST, isn't it, Mr. Mahmoud? You will say to find SST is summation of Y, because you want to focus on what? On the treatment only, isn't it? It means this will be yi dot dot dot, isn't it, Mr. Mabunda?
Yeah. Yes.
This dot dot, it means it's what and what. The dot represent what and what?
Is the sum of the treatment.
No, I mean this dot. You said I goes with the treatment. It is there. What is missing? I wrote yes. And when you see the I,
Yes, I can see.
and you said I goes with the treatment. What is not here?
Is the block and the replication
Thank you. Wait there. Is the what you are saying is the block and the what?
and the replication.
You saw where I wrote them.
Yes.
If you know the numerator, there's no way that you can fail to find the denominator. If you know the numerator, you cannot fail to find the denominator. So usually when you write the formula for SST, you say y dot 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 squared, isn't it? You're going to divide by what,
Yes.
Mr. You're going to divide by what?
N.
No, let's split that n. N is given by what? The first dot
T.
represent what?
T. T.
The second dot represent what?
B.
The third dot represent what?
R.
You see?
Yes.
You see, Mr. Mabunda, how we get these things?
Yes, now I understand.
Let's go to SSB. I want you to give me this one so that even when people they don't understand, they'll ask you. Let's go to the blocks. Blocks we say is y. We say is y dot j dot, isn't it?
Yes.
We're going to divide by what, Mr. Mabunda? You are
By
guided by those dots.
T.
T. T only.
T. T. R.
TR, isn't it? Because even that we have two dots here. These two
Yes,
dots
I
must be
see.
represented from on the numerator, on the denominator,
Yes, I
sorry.
see.
Minus y dot 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 squared divided by what? Focus on the
T.
dots.
T.
Yes,
B.
yes.
R.
Ah, let's go to the third one now. SS model. SS model, you say, is given by double summation, isn't it? Of yij dot squared divided by what, Mr. Mabunda?
By R.
By r. Minus y dot dot squared divided by what?
T.
TBR, isn't it?
Yes.
But we need the formula sheet, isn't it, Mr. Mabunda? The last one, the last one, Mr. Mabunda, is SSTO. The logic behind SSTO. SSTO is given by what? Because we have yijk, it means we have three summations, isn't it? Yijk. We have three summations here. Yijk. We are going to divide by what, Mr. Mabunda?
We won't divide with anything here.
Yes, we won't divide with anything. It was a trap by me putting the division. Why? Because everything is represented there, isn't it?
Yeah.
But we need the formula sheet, isn't it?
I said, like you are just against this thing of publicity.
Yes, we need the formula sheet.
Yes, I'm not denying that.
Yeah, ke re sharp ka formula sheet.
Sir,
Yeah, I'm not denying
Sir.
that we need it. Yes,
sir,
yes.
why didn't you say this at the
Uh,
start of this module?
Where?
Why didn't you teach us how to create these formulas when you started this module?
I showed you the notation, isn't it? Go and check my
Yes,
notes.
but you didn't explain as you're explaining now how we
Because
come
I
how
noticed
we
that you
come.
have a problem with the formulas. So I don't want you to fail because of the formula.
But if you did this back then you wouldn't have a problem
No one,
now.
no one indicated that we failed because we would spend more time maybe preparing for a certain subject or presentation. The issue was the formula sheet, isn't it? So now we noticed what is the problem. we must do what? We must solve the problem. Isn't it, my brother? We noticed what is the problem. Now the problem should be solved. Because what you did in the morning class is you suggested that because those were suggestions, isn't it? You suggested something, so you'll be given a feedback that this one is applicable, is possible. This one is not possible due to one, two, three reasons. So you see, guys, the formulas, and again, let me go back. Let me go back to this one. This one. This part, if you can check, we are going to divide by this part from the what? When you do pairwise comparison, when you deal with the treatment, you are going to divide by BR. If you are asked to do the treatment for the blocks, you know that inside that square root, you're going to divide by this. Again, if you are asked to do for the interaction effect, you divide that by what? By R. Isn't it? BR and R, you can see them from the previous, you see? This one is divided by R because you have the blocks and you have the treatments that are represented. What is not represented, what is the replication? Or what was used. So with that short notice, can we please break for 5 minutes? I'm done with what Mr. Lebo asked me to do. Yes. Yes.
Yeah, for iteration, we will have to use.
Yeah, get closer to the mic. Go closer to the mic.
So I mean, for this one, for this second one, where we have to use what again? What confidence interval for the iteration?
Yes.
So can you hear me?
Yes.
So you'll specify on which cell and which cell we must find the confidence interval, right? Or we'll have to do for all of them. Because there
No,
will be a lot.
if it's a lot, we can specify.
Yeah, okay, thank you, sir.
If it's a lot, we can specify. But for this question, there's nothing, isn't it? It's
Yeah,
just it's only
I
four
mean
means.
I get you, sir. But I mean,
Yeah, but if
maybe you
there's
find
a
that.
lot, yeah,
Okay.
we'll guide you on which side for which cells.
Okay, thank you, sir.
Enjoy. So I wanted us to break for 5 minutes. So that at 10:02, you must switch now to another model now. Another model. So there's chapter 3. We're doing chapter 3. We're supposed to go to chapter 4. But the chapter that is directly related to what you are currently doing is chapter 5. So don't be confused, guys. I said for the Friday quiz, we are going to write up to what we discussed now. This Mr. Lebo asked me to help him with this one. He's busy today. I think he's busy preparing your quiz or something. So he asked me to cover this part with you. And then what I'm going to cover from 10:02 is not part of the quiz. Don't confuse the two, guys. It's a new chapter. So it's not going to form part of your Friday quiz. Please get me right. So if you want to consult, I think Mr. Lebo will come for that Friday session. I think you'll need him if you want to. Oh, you are writing using that session, right? The quiz. It seems like you're writing in the morning.
Yeah.
So it means if you have some questions that you want to ask, it means you can direct them to Mr. Lebo. Unless if you want to ask about what I'm about to cover now, which is Latin square design, is chapter 5. We know we still owe you chapter 4, but chapter 5 is directly related to this chapter. You remember the example that I gave you about the tires, fitting the tires to the car, and then I said the way we assigned the randomization was done. It can create some problems, but we can correct it when we get to Latin square design. So now I have to link the two. What I'll first project what I said last time here before I can get to the new chapter so that we can connect the two models. So let's go for break until 5:2. I'll be looking for that document. From there, we continue with a new chapter. Take a 5 minutes break so that we warm up to the new chapter. I thank you.
We can continue, sir. We can continue, sir.
Sir, not
Welcome back, guys. I was still having a chat with Tatilbo about something. So you remember the? Let me stop sharing this one. Yes, 4 o'clock now. It's fine. We're left with 30 minutes. I just want to introduce this section about Latin square design. But before I can do that, I want to take you back to what we discussed. Let me share the document with you. Oh, I have to close this. Sorry. So the only difference between what we have been doing with this new chapter is that we increase the number of blocking factors. We increase the number of blocking factors. So far, we are dealing with how many blocks? One block. You are blocking by a row or a column. Can you see the notes? Remember this example, guys? And there's a confusion. Some students were coming to me and saying experimental units are blocks. No, guys. Experimental unit is a controlling factor. It's not, no, sorry. A block is a controlling factor. Experimental unit is where you are going to apply your what? Your treatments. Experimental unit is where you are going to apply your what? Apply your treatments. For example, Mr. Levo gave you an example in class which was talking about the starting salaries of the UL graduates. You cannot say experimental unit is those subjects. Experimental units there is where you're going to apply those methods. You're going to apply to what? Do the employees. Employees are the what? Employees are the experimental units. So don't confuse the two, guys. Block is a variable which we bring in, which we are trying to control our experiment.
Sir,
Yes.
sir,
I'm listening.
then isn't it that inside the experimental unit we find the blocking?
Inside the
Experimental unit.
yes. You experimentally, it's fine. Thank you very much for that question. What I'm saying, my sister, is that you have the experimental unit, isn't it? Or let me go to the whiteboard to make life easy. These are let me see. These are the experimental units, my sister, isn't it? Experimental units. These are the employees. Employees, isn't it?
Yeah.
You see, my sister. From these employees, I'm trying to relate to that example that Mr. Libo did in class. You want to check the starting salaries of what? Of the university graduates. But before you can assign them to those years, you first divide them based on what? Based on what they have what? They have completed with computer science, statistics, and mathematics. Do you see it, my sister? So you cannot say blocks are what? Are experimental units. No, you manage
Oh,
to, yes.
yes, we're not saying the experimental units are blocks, but we're saying
That's
or
what I was
inside.
told today. Yeah, someone consulted. I'm referencing someone based on someone who said it in my in the office today. So I thought maybe it's not the only one, but if you understand, it's fine.
Okay.
Yeah, as long as you understand, it's fine. I'm just correcting the point where people are confusing experimental units and blocks.
Okay.
Yes, I'm trying to correct that part. Um, so before, I don't want to rush to get to that new chapter without you guys understanding this one. So you remember this example. I mean, remember this example that which was talking about the cars. Um, I said, looking at this example, this is randomized block design. Assume a random assignment for block design. Suppose now you want to apply randomized block design. Here it is applied, but the challenge now is one. Car A, it is safe. It is it managed to get all what? All the brands. We're having 4 brands of tires, isn't it? Car A, it was able to get what? All the brands, isn't it? Car B, again, it managed to get what? All the brands. Car C, again, the same thing, isn't it? And the last one managed to get all the brands. But the challenge is one. Where are the tires placed? Remember, when looking at the car is supposed to have how many tires? 4 tires. Check brand B. Brand B was never exposed to the what? To the left side of all these cars. Left front, the front tire, but on the left side. You don't have brand B here. So it was never exposed to what? To that position. Same applies to when you're coming to the second one here. For all the cars, the right front brand what? Brand A was never exposed to that side. That is why I said There are other methods that can be used too. So I indicated that notice with this design and random assignment that each brand is exposed to all the forecasts, so comparison of brand will not be influenced by the effect of the cars. It is possible with the above randomization that all tires of the brand are put on the same wheel position. You see, like this one, B and B. This type of this type is exposed to what? Right front. You find that it was never exposed to what? To the other sides of the car. I said uh, the alternative method for alternative blocking design that can be used is called what? Latin square design. So now we want to improve this. Now when we continue from this example. We want to assign these numbers. The numbers here represent the three, but I will explain when I get to chapter 5. We must arrange these numbers in such a way that they are exposed to all the what? Are exposed to all the sides of the car. So now, that's where now the new chapter comes in. The new chapter is called Latin Square Design. Here's the information of Latin Square Design, which is chapter 5. Let me share the notes. So today I will just talk about the theory part of it. Next week, Wednesday, because Tuesday we're going to convert Tuesday to be a class, a tutorial. Wednesday, we'll continue with this section. I just want to come up with the introduction part of it. So now, here's your chapter 5. Chapter 5 is Latin Square Design. With the difference between this design and chapter 3 is because here you are having what? You are having two blocking factors. Can you see it, guys? For randomized block design, you are having one blocking factor. For Latin square design, the general one, this one is the general one. There's another one that will cover after this one is called Graeco. Graeco Latin square design. That one, it will have three blocking factors. It will change this one to 3. Immediately you see 3 blocking factors, it means it will become Graeco Latin square design. But now our focus is only on 2. So the one with only 2 blocks, we call it Latin square design. It says this is a standard one. In general, a Latin square design can be used to a T treatment means in the presence of 2 blocking factors. In the presence of 2 blocking factors. Remember, the reason why I was emphasizing the issue of blocks. Why do we bring the blocks in when we are solving our problems? I said it's possible that maybe you might be dealing with the CRD problem to try to get something, maybe concerning those teaching methods. But when you are busy with your experiment, you have a feeling that no, this experiment maybe is my results are affected because of some sources or something. So what you do, you bring in that thing into consideration that you think is affecting your result, and you control your experiment using those variables. So in our case of Latin square design, instead of bringing one block, we are going to bring 2. But our design is always a T by T design. Our design is always a T by T design. If you have 4 blocks, it means you have 4 treatments. If you have 4 blocks, it means even your treatments are 4. If you have 10 blocks, it means even your treatments there are 10. So the treatments, the blocks will be represented by what? The blocks will be represented by the rows, and the columns will be represented by what? And the other block will be represented by the column. So whatever is on your row is your block. Whatever is indicated from your column, again, is your block. The treatments now, they will be represented by what? They will be represented by the letters. The treatment will be represented by the letters. But there is a condition now assigned to those treatments. Here it is. The T treatments are randomly arranged to the rows, which is the block 1, and the columns, which is the second block, so that each treatment appears in each and every row and each and every column. Let's get the definition right. The treatment will be arranged in such a way that they appear once in each row and in each column. So we should not have a case where when we check the treatment from a certain row, they are repeating. Maybe you find AA, like the one that I projected. This example does not qualify to be a Latin square design problem. This one. Let me stop this one. I want to share this one so that you. Yes. You see this design? Yes, leadership?
So,
Yes.
does it mean the problem must always be balanced?
The problem must always be balanced. It's a T by T. It's a square. A square of all the sides are the same, isn't it?
Okay.
Yes. So if, like in this case, our block here can be what? Can be the type of the car, isn't it? I said what is appearing on the left should be what? Should be the what? This one, it means the car is what? Is block 1. These are the blocks. I said the rows will represent what? The block, the rows will represent the blocks, and the column will also represent what? Column will also represent the blocks, isn't it? The letters from each and every cell will represent the treatment. So in short, let's write it. Column row is equal to car, type of car, type of car. This is the block, isn't it? This is the block, the first block. The second block, what is on the column? What is on the column is the what? Is the position, isn't it? Position is the position of the tire position. Where is it placed? This is what is the second block, isn't it? This is also what? A block. We're done. We're saying the position where the tire is placed is the block. The type of the car, again, is another block. So this block 1, this is block 2. What are our treatments? I said the letters represent the letters represent the treatments. What are the letters representing? The brands. Yes, Mabunda.
Can you please repeat, sir? I mean, I do not understand from that part
sorry,
of
sorry, it's
road.
fine. I will repeat. I said the definition of Latin square design. We are going to have 2 blocking factors, isn't it? What is on your row? In our case, is the what? Is the 4 cars. These 4 cars, you are blocking by the car, and also blocking by what? the position of the tires, isn't it? Where is the tire placed? So whatever is appearing on the heading there is the block. Whatever is happening on the rows, again, is also the block. The letters, the treatments are represented by letters. So you must go back to the statement. What are these letters representing? These letters. What are these letters representing? These letters represent what? The brand, isn't it? The brand of the tire. Where this tire is what? Yeah, it is. Remember this part, my brother? The
Yeah.
brand will represent the treatment. So whenever you are given a Latin square problem, whenever you see the letters, just trace those letters represent what. Whenever you see the letters from the problem, it means those letters represent the treatment. If you are asked to uh, uh, calculate for the treatment, you just look for what? For those letters, write them down, find that, but that one will do it next week, Wednesday. So, but there is a condition that was placed that these letters, the letters that you see now, the letters that you see, they should appear once and only once in each row and column. So can we say this layout qualifies to be a Latin square design problem? The definition says these letters, when we check them, row-wise or column-wise, they must appear strictly once and only once in each row and column. What is the problem with this layout?
They don't appear once.
There's
So,
repeating letters.
you see, here we have DD, it's a problem, you see? So this one, so before we can solve our problem, we must first make sure that this problem is solved, you see, AA. So this cannot be what? A Latin square design layout. So now I want us to go back to that one and then let's practice what? How to find the layout of Latin square design with the remaining 10 minutes. It's a lot. From there, as long as we have the idea of what is going to happen, next week we'll do the examples. Let me go back to that note, those notes, the notes.
So I've been hearing
Yes.
you saying that next week. So tomorrow there's no class, there's no tutorial.
Tomorrow is Thursday, isn't it? Tomorrow we don't have a class.
Okay.
Are you able to? Oh, okay, it's fine. So now already you indicated that layout that I showed you, it doesn't qualify to be a Latin square design problem because some of the conditions are what? Are violated. The treatments are not randomly assigned to rows and columns in such a way that they appear once and only once in each row and each treatment. So you have an issue with that layout. So here is the general definition now of Latin square design. A definition, a Latin square design is a T by T Latin square design contains a T rows and T columns, where the T treatments are randomly assigned to experimental units within the rows and the columns, so that each treatment appears in every row and in every column. This statement is the same as this statement. Those two statements are the same. They're just written in different ways. So now I just defined what is a Latin square design, right? So every row contains all the Latin square letters, and every column contains all the Latin square letters. if you can check the one that I presented, you may find that when looking at the rows, that condition is covered. Looking at the example that I just projected, when looking at the rows, all the letters are there, but the condition when looking at the column is violated when coming to Latin square design. So, sorry for that. A general Latin square design has the following features. Is the one that will be doing. There are T treatments. There are two blocking factors. We have two blocking factors. The treatments are randomly assigned to experimental units. It was just a summary, that one. So I want us now to go back to, now I want you guys to give me an example of this Latin square design. And this one now, there's what we call standard Latin square design. Standard Latin square design, it means each row and each column will have the alphabet will be arranged in alphabetical order. If the letters, this is very, very important again, if the letters in the first row and the first column are arranged alphabetically, then the Latin square is called standard Latin square design. Let me repeat. If the letters in the first row and the first column are arranged alphabetically, then the Latin square is called a standard Latin square design. Let's go to an example, practical example. We're not going to do any calculations with the remaining. So now I want to write now. Based on those definitions now, I can create questions, and then leaders will start answering the, sorry, where do I go? We're almost done, guys. Can you see the board?
Yes.
Oh, thank you. Well, we're done now, guys. We're done. I know you're tired. Let's differentiate the two. Suppose we have a column, or sorry, row. 1, 2, 3. Column 1, 2, 3. Suppose we're given this problem. I want you to tell me which one is a standard Latin square design, and which one is A, C, B, if I put A here, I'm safe. I put B here. What type of Latin square design is this one? Is it a standard Latin square design, or can we say this layout qualifies to be a Latin square design? Let's start from there.
This one
Yes.
is a standard.
Why? Why? Reasons? Give me the reasons.
Because the
You're saying it
letter.
qualifies to be, yes. Reason number one.
Because
It's
the
a T by
letters are
T
not.
design, isn't it? Because we have three, it's a 3 by 3 design. Am I wrong? 3 rows, 3 columns.
No.
So it's fine. 2. What is the other reason? Why are you saying it's a Latin square design? What else is guiding you? Give me the reason based on the treatment.
Retreatment.
The letters in the first row and the column are not arranged in alphabetical order.
No, I mean, before we say it's a Latin, it's a standard or what? Why are you saying it qualifies to be a Latin square design? If I change,
Retreatment.
sorry?
The letters does not repeat
No
on
repetition.
the row and column.
Thank you. There is no repetition of the letters, isn't it? In any row or in any column. So that is thumb up. We are safe. There is no repetition of any letters in each row and each column. But now, if I give you this one now, oh, sorry, let me write it here. Column 1, 2, 3. This is the row. A, B, C, B, C, A, A. But what is missing here? This is supposed to A, B, C. And then this is supposed to be what? C, right? And this one can be A. And this can be B. What type of a design is this one? Is it a standard Latin square design or is a general Latin square design? It's just a normal Latin square design.
Standard.
Standard Latin.
Standard. It's standard Latin square. So differentiate between standard Latin square design and Latin square design. Differentiate between the two.
The first row and the second, the first row and the first column, the treatments are in alphabetical order.
Yes, but with Latin square design, it's not a must that the first column and the first row should be assigned in alphabetical order, isn't it? Because you said if I change this Latin square, if I change this to BA, let's say we're 4, let's say we're 4, DCAB, A, B, C. Can you please complete this, guys? We have a 4 by 4 Latin square design. Tell me the letters. What am I supposed to write here? Try it, guys. Try it. Let's find a Latin square design, a 4 by 4. Suppose your first row and the first column is like that.
There you can write C, say.
C. The last one is A here. It's what? So it's B. Isn't it? Let's go. So it means here is A, isn't it? Because I have A, B, C, D.
Yeah.
This one I'm left with. So there's a problem with this design, isn't it?
Yeah.
So it means this one should be what? Should be B, isn't it?
Yes, it should be B.
This one would be what? You see, it's not possible. So I want us to come up with a design which is a 4 by 4. It's a 4 by 4, but when you're given a test, you won't be asked to arrange these things in like this. You must know how to use the given information. So this section is the easiest section ever. Even the formula that will be given there, they're straightforward, are not even complicated. Because remember, always T is treatment is equal to block 1 is equal to block 2. So if I say given 3 treatments, suppose this is a Latin square design where your treatments are 3. You cannot ask me how many number of blocks do we have? Because of what? You know the definition. This is a T by T design, isn't it? If I give you 3 treatments, you know that we have 3 blocks and all the column are also 3 and the blocks are also 3, isn't it? So next week when we meet, someone's mic is on. Can you please call the leader to order? Someone's mic is on. Hala, you are making noise.
No, Alex, please mute your mic.
No, it's sorted, the brothers. So the next chapter is not that complicated. It's easy to identify what is your treatment. I said always whenever you see the letters, they represent your treatment. So I don't think you'll have a problem with that. Just need you guys to focus. Otherwise, I will stop here for today. But please don't relax, guys, and accumulate this week. Remember, next week we'll start writing, isn't it? We'll start writing tests. Some of you may decide not to attend classes, and there's no way that you come to my office and then you want me to teach you from scratch while you are not in class. For example, now, even though you defended them in the morning, you are only 83. Where are the other students? So you are the only one who can afford the data, because you are busy defending them that they cannot afford the data is not enough, but you are here. So please help them to take these things serious. Even if we say what is 1 + 1 in a test, someone will get it wrong. So please, guys, let's work together. Let's work together, and then we'll see. I thank you.
Sir,
Yes, Mr. Wanda.